Okay, so we are going to take a good look at the triangle proportionality theorem and its converse. And of course, whenever we talk about a converse, that means if we go in one direction, we can also turn around and go the opposite direction and undo it. All right, so it looks like the whole gang is showing up for this. Just about every peanut character you can possibly imagine is showing up, including good old Woodstock. Come on, Woodstock, catch up with everybody else. Gotta clear the screen, Woodstock, so I can go to the next slide. Okay, I think Woodstock made it. Let's go to the next slide. Okay, the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionately. All right, so I've got triangle QRS, right, large triangle there. And then it looks like we've got TU, which is a parallel segment to QS. And if those are parallel, then the ratio of RT compared to TQ has to be equal to the ratio of RU compared to US. And then, of course, the converse. Well, if you already knew those ratios were equal to each other, then you know those line segments have to be parallel, right? So we can go both directions. So let's take a look at a couple of examples. Got triangle, right, URT, and then we also have a segment drawn on there, segment QS, and the markings on the diagram tell us that those are parallel, and in the directions it tells us they are parallel. So I know that R to Q has to compare to Q to U the same way the distance from R to S compares to the distance from S to T. All right? QU, of course, is 9. RS is 4. ST is 6. And hey, how did we start this whole unit? Cross multiplication, right? 6 times RQ equals 9 times 4. Of course, 9 times 4 is 36. So RQ has to have a value of 6. Right? The length of RQ is 6. Okay, here's another neat little example. Can we find the length of segment IT? Okay, we can do some proportionality because we've got some parallel segments. So I know from G to T that is 20. Right? From I to T is X. From G to E that is 10, and from E to R that's 6. So I know GI compares to IT the same way that GE compares to ER. Now, if you look at the diagram, we're kind of missing what on earth is GI? Well, I know GT is GI plus IT. And I know GT is 20. I know IT is X. So what on earth is GI? Well, it's got to be 20 minus X. Right? So GI is 20 minus X. IT is X. GE is 10. And ER is 6. Cross multiply. Use the distributive property. Add 6x to each side. Divide by 16. X has to be 7.5. 7.5. So the length of IT is 7.5. Okay, let's find the length of RS. Oh, this looks like it's going to be much more exciting. Okay, again, I know RO compares to OH the same way that RS compares to SE. Plug in all the corresponding values. Cross multiply. It looks like I need to do FOIL on the left-hand side. All right, x times x is x squared. X times 7 is 7x. 4 times x is 4x. 4 times 7 is 28. Of course, on the right-hand side, 18 times 10 is 180. Let's combine like terms. 7x plus 4x is 11x. And let's get this set equal to 0. So I got to subtract 180 from each side of the equation. X squared plus 11x minus 152 equals 0. Two sets of parentheses. All right. And I got to figure out, well, what's going to multiply to be 152? I actually only have 4 choices. All right. Do any of those choices have a difference of 11? Yeah. All right. 19 times negative 8 makes the negative 152. 19 plus negative 8 makes that positive 11. So if I did FOIL, the 19x from I and the negative 8x from O would combine to be that 11x. So it looks like we're going to get 2 answers. Right? Set each factor equal to 0. Solve each one. I've got 2 answers. Wait for it. Wait for it. RS is supposed to be x plus 7. Does negative 19 plus 7 give me a valid solution? No. We are going to assume that the distance on any polygon or any part of any polygon is going to be positive. Well, let's try 8 plus 7. Yes, that is certainly reasonable. RS could indeed be 15. Looking at SE being 10, looking at RO being 18, you're like, hey, even if I just eyeball the picture, 15 seems like a really reasonable answer. Yeah, so the length of RS is 15, right? So one of those 2 values of x did not lead us to a valid solution. Okay, is anything going to happen here? Ah, hey, the whole gang's showing up. And it looks like we've got a worksheet, but I do not see any announcement about an IXL assignment. So it looks like for today, it is only a worksheet. Again, if you start struggling and get caught up, have questions, are confused, whatever, send me an email, and I try to reply as promptly as possible between 9 a.m. and 2 p.m. But some of you have noticed if you send me an email at odd hours of the day that sometimes I still get back to you pretty quickly. As a reminder, we should only be spending about 80 minutes on a math class, unless, of course, it's Friday, then it's a shortened period. But if you're finding yourself spending way more than 80 minutes on your math class, or any class for that matter, contact your instructor. We really don't want you just spinning your wheels and spending tons and tons of time. You should be able to complete the assignment for most any class, I would hope, in less than 80 minutes, even if you take a couple of short breaks in that time frame. And by short breaks, I mean like 5 minutes, nothing lengthy. But if you're at a point where it's taking you just forever to complete an assignment, contact the instructor. I don't care what class it is. We're not trying to make school so horrible that it's not enjoyable. We're not trying to overwhelm you with too much work. Every so often I hear a student complain that they're not getting enough work. Well, hey, you can always read a book or do something. But we're not trying to overwork you here, okay?